May 28th, Blue Origin detonates a rocket on the pad. That same week, SpaceX catches a booster with the Mechazilla arms for the first time in history, then pulls the entire catch rail system off, replaces it with a new one in a matter of days. And that same week, China quietly launches a brand new rocket. No announcement, no NOTAM, no press conference. Nobody knew it was coming. 21 months from drawing board to launch pad. 3 events. 1 week. One company is cleaning up wreckage. One company is upgrading hardware right after pulling off a milestone. And a competitor across the Pacific is quietly closing the gap in ways most people aren't watching. So the real question isn't who won or lost this week. The question is, what operating principles are reshaping this entire industry? Today, we break it down piece by piece. Blue Origin is running an engine test on the pad. A short pop, no sustained burn, no engine ignition sequence before it. Just a fireball. New Glenn's only launch pad at Cape Canaveral is destroyed. That same week, SpaceX completes Flight 12. The booster is caught by the Mechazilla chopstick arms. First time in history. The ship hits its target in the Indian Ocean. Then SpaceX pulls the landing rails off both arms, replaces them with new hardware. Days later. That's the starting point for today's analysis. Not who won, not who lost, but this. Why did 2 companies in the same industry end up in completely opposite states in the exact same week? The detail nobody's talking about, the comm bunker and the chopsticks. This is the most interesting part of the entire story this week. Based on aerial footage from RGV Aerial Photography's flyover on May 30th, just days after Flight 12, there's one detail in the report that almost nobody covered. An old bunker at Pad 2, housing control and communications equipment, sustained damage during Flight 12. Not severe damage, not the kind that threatens primary systems. But here's what makes it worth stopping on. The section of wall that hadn't been upgraded to reinforced concrete broke. The section that had been upgraded, completely intact. The flyover report noted this damage may be why the chopstick arms came down later than expected right after Flight 12 launched. Think about what that means. The chopsticks need to come down at exactly the right moment to catch the booster. Not approximately right, exact. We're talking meters, seconds. If the control equipment inside that bunker absorbed enough vibration to respond a few seconds late, that moment the world called historic could have gone very differently. Not a failure of technology being insufficient, a potential failure caused by one section of unreinforced concrete. And here's the most important takeaway from this small detail. What did SpaceX do? No press release, no press conference. They fixed it immediately. The new landing rails, why this matters. In parallel with the bunker repair, SpaceX pulled the landing rails off both Mechazilla arms and replaced them with a new version. Based on flyover imagery, the new version features cutouts machined directly into the rail body for weight reduction. The internal bracing configuration has also been refined. Sounds like a minor change. But here's the more important question. Why do this right after Flight 12, not after Flight 15, when more data would be available, not after an actual failure? Right after Flight 12. That tells you something. SpaceX read the data from a single flight and decided this hardware could perform better right now before the next mission. That's not the process of an organization trying to hit milestones. That's the process of an organization running continuous optimization. In engineering, there is a concept called iteration velocity. Not who does the most, who learns the fastest from each attempt. The data coming out of Starbase this week shows that Loop is running on a timescale of days. 2 philosophies, not 2 levels of engineering. Here's the core point most analysis is missing. The gap between SpaceX and Blue Origin this week is not a technology gap. It's not a funding gap. Blue Origin has Jeff Bezos behind it. Funding is not the constraint. The gap is in design philosophy. SpaceX built all of Starbase around one core assumption. Hardware will be replaced frequently, and that's by design, not by accident. Look at what's happening at Starbase in just this 1 week. Landing rails replaced after 1 flight. The bunker being repaired and upgraded to a new structural standard. And while Pad 2 is being assessed after Flight 12, Pad 1 is being constructed in parallel. Based on flyover imagery, the foundation for Pad 1's GSC bunker is nearly complete. The rebar cage is in position. Pre-assembly of the bunker structure is approaching final form. And on June 2nd, the first flame trench wall panels for Pad 1 arrive on site. 2 launch pads at the same time. That's not luxury, that's designed for worst-case scenarios. SpaceX isn't building Pad 1 because they need it right now. They're building it because they know any single launch pad will eventually go down. And when it does, the program cannot stop. Blue Origin's design philosophy is the opposite. Build it right. Build it once. Build it to last. That philosophy isn't technically wrong. It put humans on the moon in 1969. But it has one very specific vulnerability in this era. When something fails, you have nothing to fall back on. No backup pad. No hardware designed for rapid replacement. One path forward. And when that path is blocked, everything stops. NASA pressure and the strategic void. This isn't just a technical story, it's also a story about pressure from the industry's largest customer. That same week, NASA Administrator Jared Isaacman flew to Cape Canaveral. He met directly with Jeff Bezos and Dave Limp. He saw the destroyed pad with his own eyes. And then he said straight out that 2028 is within the realm of possibility for LC-36 to return to flight. Meanwhile, Blue Origin CEO Dave Limp says they'll fly again before the end of 2026. 2 people, 2 numbers, 2 years apart. When the buyer and the seller are that far apart on timeline expectations, that's a credibility crisis, not a technical disagreement. And Isaacman has started suggesting that the Blue Moon lunar lander may not fly on New Glenn after all. Not a contract cancellation, just a suggestion about contingency options. But a suggestion like that from the head of NASA carries a very different weight than a casual comment. In that same window, what is SpaceX doing? Transport stands, BTR-2 and STR-2, have been moved to port in preparation for Florida operations. Expanding operational footprint, not contracting. One side is managing a credibility crisis with its most important customer. The other is expanding. China, the quietest competitor of the week. That same week, there was a third event. Most channels didn't put it next to the other 2. A brand new Chinese rocket quietly lifted off. No prior announcement, no NOTAM, the standard airspace restriction notice that protects commercial flights. No press conference, no launch event. According to This Week in Spaceflight, this is unprecedented behavior for modern commercial launch history. The rocket is the Changzheng 12B, and the number that matters most isn't the rocket's designation, it's 21 months. That's the time from design to launch pad, a claimed industry record for the Chinese space sector. Before analyzing that number, one thing needs to be stated clearly. A 21-month timeline isn't purely a product of raw engineering capability. China operates with a different support ecosystem, different certification standards, different approval processes, and forms of state backing that US private companies don't have access to. But the speed is real. And more significant than the development timeline is what they put on the rocket during its very first flight. Mock-up landing legs, grid fins. They didn't launch to prove the rocket could fly. They launched to collect reusability data from Flight 1. This is the approach SpaceX pioneered with Starship. Every flight is a targeted experiment. Not just don't explode. China is now applying that philosophy with a development loop velocity that no one in the West can afford to ignore. The full picture. What operating principle is winning? 3 events, 1 week, 3 perspectives on the same race. SpaceX finds minor damage after a historic milestone. Replaces hardware immediately. Builds Pad 1 while Pad 2 is still operational. Learning loop runs on a timescale of days. Blue Origin. One anomaly destroys the only launch pad. CEO and largest customer are 2 years apart on timeline projections. No backup infrastructure to continue operations while rebuilding. China. New rocket flies with no public warning. 21 months of development. Reusability data collected from Flight 1. No performance required. Looking at all three, the real question isn't who has the most powerful rocket. The question is, who is building the fastest learning system? Because in an era where good hardware is necessary but not sufficient, the thing that actually creates distance is the speed of the loop from anomaly to improvement. SpaceX replaced the Mechazilla landing rails within days of Flight 12. Blue Origin will spend months, possibly longer, just clearing the pad before rebuilding can begin. That's not a money gap, not a talent gap. It's a gap built up through hundreds of small design decisions, each one seemingly minor in isolation, that compound into fundamentally different systems when a crisis hits. 20. Cryo cycles, the question nobody is asking. Before we close, one detail from Massey's test site this week that nobody is asking the right question about. Test article 18.3 just completed its 20th cryo test. Not 5, not 10. 20 cryo cycles on the same tank. Frost was still clearly visible on the tank surface the morning after the June 2nd test, indicating the tank is being pushed through repeated cryogenic thermal cycles at very high intensity. Historically, a standard Starship test article wraps up after 3 to 7 cycles. So why 20? Two possibilities. Both matter, but in different ways. Possibility 1. SpaceX is working through a technical issue with a specific parameter on this new tank design. Each test cycle represents an incremental adjustment followed by verification. 20 cycles means that loop hasn't reached its target yet. Possibility 2, and this is the more interesting one. SpaceX is deliberately collecting fatigue life data, material durability data, for repeated cryogenic thermal cycling at this scale. Why does that matter? Because a rocket on Mars has no maintenance crew, no engineers on site to inspect after every flight, no Massey's pad to run one more cryo cycle. If SpaceX is building a fatigue life dataset for composite cryogenic tanks at this scale, then 20 cycles isn't a sign of a problem. It's a sign of a program preparing for something far beyond the next flight. No space agency in the world currently holds this data for composite cryogenic pressure vessels at Starship scale. If 18.3 is generating that dataset, this is one of the quietest and most consequential pieces of work happening at Starbase right now. And almost nobody is talking about it. The real question isn't when they stop testing 18.3. The question is, what number are they looking for, boy? And when do they find it? That question, what number 18.3 is chasing, will have an answer when the data gets clear enough. For now, if this analysis gave you a different lens for reading this week, that's everything the Space Brief is here to do. Like and share if this was valuable. Subscribe if you want to keep breaking this down together. Drop your perspective in the comments. I read every single one. Thanks for your time.